Chapter 2: Choosing your respirator. As a mold busters technician, I can tell you that choosing the right respiratory protection is a complex process, best left to seasoned safety professionals or occupational hygienists. These experts, familiar with your specific workplace environment, will be able to make the best decision. Before selecting respiratory protection, it's crucial that the individuals responsible for your workplace's respiratory protection plan have identified any present respiratory hazards, evaluated these hazards, and considered the feasibility of engineering controls. In addition, they should have considered all relevant factors within the environment, which can include, but are in no way limited to, whether the respiratory protection will be used for firefighting or emergency response, whether it will be used in oxygen-deficient atmospheres, in which the concentration of oxygen in the air is below 19.5%, the nature of the hazard. In other words, what are the hazard's chemical properties, airborne, concentration, and warning signs? Whether there are multiple airborne contaminants present. Whether the airborne contaminant is a gas, vapor, biological agent, particulate, that is, a mist, dust, and/or fume, or a combination of the four. Whether airborne contamination levels are above or below the acceptable exposure limit. Whether airborne contamination is at or above levels that could be immediately dangerous to life or health. The health effects of the airborne contaminant. For instance, is it carcinogenic, potentially lethal, irritating to the eyes, absorbed through the skin? The characteristics of the work environment, such as in a confined space and/or subject to elevated temperatures. The work that will be done while wearing the respirators, such as welding or heavy lifting. The length of time workers will need to wear their respirators. Whether the selected respirator fits all workers properly. The location of the nearest safe area with breathable air. Using the right respirator for your job and work environment is crucial for ensuring your safety. The two main types of respirators are air-purifying respirators and supplied air respirators. Air-purifying respirators. APRs remove contaminants from the air that you breathe by filtering out particulates, such as dust, metal fumes, and/or mists, or by absorbing harmful gases and vapors using a sorbent, or absorbing material, contained within a cartridge or canister. As air is pulled through the filter or cartridge, the contaminant is removed. Because air must pass through the filter or cartridge to be cleaned, a proper fit is crucial for ensuring the wearer's safety. APRs should be tight-fitting, and come in several forms: mouth-bit respirators, which fit in the mouth and come with a nose clip to hold the nostrils closed. Note that these types of respirators are meant for escape purposes only, they are not suitable for regular, everyday use. Quarter mask respirators, which cover the nose and the mouth. Half mask respirators, which cover the face from the nose to below the chin. Full facepiece respirators, which cover the entire face from above the eyes to below the chin. Full facepiece respirators have the added benefit of protecting the eyes from exposure to chemicals and other irritants. APRs come in three main classes: particulate respirators, also known as dust, fume, and/or mist respirators, and masks, use particulate filters to remove contaminants from the air. Chemical cartridge respirators, which are used to remove harmful gases and vapors using chemical cartridges. Certain chemical cartridge respirators can work with a combination of chemical cartridges and particulate pre-filters. These combinations can provide protection against multiple different kinds of contaminants in the air. Powered air-purifying respirators, which use an electric motor-driven pump to force outside air through a filtration system. Chemical cartridges are used to remove hazardous gases and vapors from the air you breathe. Some contain a sorbent material, such as activated charcoal, which absorbs contaminants. Others contain a chemical compound that reacts with specific contaminants in the air, changing them into harmless gases. Particulate filters are made of a fibrous material that traps particles as you breathe in and provides protection against particulate contaminants. They come in 9 classes, depending on the particulate material, filter efficiency, and oil resistance. The main categories of oil resistance are N-series filters, which are not resistant to oil and may be used in any atmosphere where there are no oil particulates. R-series filters, which are resistant to oil and may be used in any atmosphere where there are no oil particulates or for up to one shift in an atmosphere in which oil particulates are present. Note that one shift in this context means 8 hours of continuous or intermittent use. P-series filters, which are oil-proof and may be used in any atmosphere, including those with oil particulates present, for more than one shift. Note that if the filter is used in atmospheres with oil particulates, you should contact the manufacturer to determine its service life. Oils and other airborne hydrocarbons can break down certain types of filters, so it's incredibly important to always know the materials you're working with and around in order to select the right filter for your respirator. Each of these series of respirators, N, R, and P, are then classified into 3 levels of filter efficiency. Filters are rated as either 95%, 99%, or 99.97% efficient, based on their ability to remove particles 0.3 micrometers in diameter. Taken together, this means that a filter rated N95, for example, is not resistant to oil and is at least 95% efficient at removing particles 0.3 micrometers in diameter. 99.97% efficient filters are also referred to as NIOSH 100 series or HEPA filters and are commonly used to control exposure to extremely small biological contaminants and airborne particulates, such as hantavirus, asbestos fibers, and lead and cadmium fumes. The most commonly available filters are rated N95 and P100. Because filters work by capturing harmful particles, it is vital that you regularly check and change your respirator's filters to prevent them from clogging. Clogged filters make it harder for air to pass through them, which in turn makes it difficult to breathe while wearing your respirator and can lead to the development of leaks in the seal. Chemical cartridges can also become full when the sorbent material within becomes oversaturated and cannot absorb anymore. This results in a breakthrough, in which the harmful gases or vapors the cartridge was meant to absorb seep through into the respirator. Both filters and cartridges must be replaced regularly as per the manufacturer's recommendations. Many manufacturers use warning properties or end-of-service indicators to indicate when their filters or cartridges should be replaced. It is vital, when using APRs, that you make sure you are using a filter or cartridge that is suitable for the work you will be doing and the contaminants that will be present on your job site. Don't use an N-series filter, for instance, if you will be working around oil mists or sprays, or a 95% efficient filter when working with tiny particulates such as asbestos. If using chemical cartridges, make sure the cartridge you've selected will adequately protect you against the specific gases and/or vapors present. Not all cartridges will be effective against all gas and vapor contaminants, so when choosing a cartridge, it is vital you know which specific hazards you will be exposed to. Also, never use just a filter for protection against gases and vapors, and never use solely canisters for protection against particulates. These purification systems were never designed to protect against those contaminants, and will therefore not prevent you from breathing them in. Instead, in environments where both particulates and gases and/or vapors are present, use a combination filter. These filters consist of both a filter and a chemical cartridge, and will therefore offer protection from both kinds of contaminants. Additionally, cartridges and filters are not effective over a certain concentration of contaminant and do not protect against certain contaminants at all, such as nitrogen dioxide, nitric oxide, and nitrous oxide. They should also never be used in oxygen-deficient atmospheres, as they do not supply you with additional oxygen. All they do is clean the existing air around you. If your work environment contains an unsuitable concentration of contaminants, a contaminant against which APRs are ineffective, or an oxygen-deficient atmosphere, supplied air respirators, SARs, should be used. Supplied air respirators. In contrast to APRs, SARs do not purify the air you breathe, but rather provide you with a clean air supply from either a portable compressed air tank or through an airline connected to an external tank or compressor. SARs can have either tight-fitting or loose-fitting respiratory inlets. Respirators with tight-fitting inlets have either half or full face pieces, while types with loose-fitting inlets can be hoods or helmets that cover the head and neck, or loose-fitting face pieces with rubber or fabric side shields, which are supplied air through airlines. SARs come in 2 major types. Self-contained breathing apparatuses, SCBAs, where the air supply is provided by a compressed air tank that is carried by the wearer, typically via a backpack-type harness, and supplied air, airline, respirators, where the air supply is provided via an airline from an external tank or compressor. Some SARs are available that have a combined airline respirator and SCBA. This combination allows wearers to work for an extended period of time in environments that are oxygen deficient or contaminated with toxic airborne contaminants. The auxiliary or backup SCBA allows the worker to escape the hazardous environment with an emergency source of air if the airline source fails. This combination of supplied air, airline, respirator/auxiliary SCBA units, as well as ordinary SCBA respirators, are the only 2 types of respirators that should be worn in oxygen deficient or IDLH atmospheres. There are also combination APR/SAR respirators available. These devices offer protection to workers if the supplied air system fails, so long as the proper air purifier units are selected. However, these cannot be used in oxygen-deficient atmospheres or environments where the airborne contaminant concentrations exceed IDLH levels. In addition to oxygen-deficient and IDLH atmospheres, SARS should also be used to protect against gases and vapors with poor warning properties, such as chloroform, methanol, or diisocyanates. If a worker were to use an APR with chemical cartridges to protect against these contaminants, their poor warning properties would mean that, in the event of a cartridge breakthrough, the worker would not notice their exposure until it's too late. Using SARS to protect against hazards with poor warning properties removes the risk of cartridge breakthrough, therefore also eliminating the risk of accidental overexposure.